In this video, we're going to look at Unit 3, Lesson 1, which is about scale drawings. For Activity 1, we see a picture of 3 hippos, and Diego took a picture of the hippo and then he edited it. And then we want you to figure out which one is the distorted image. So this is the original image that Diego took a photo of, and then he edited it into image A and B here. So this one is A and this one is B. So which one looks distorted, meaning significantly different from the original? So here's the original. And so if we take a look, it looks like this A hippo is smushed, right? It looks like it was just smushed or pushed down, okay, but not skinnier. So it looks smushed. It looks like a little bit fatter or wider proportionally than the original, right? So this one looks smashed or smushed. And so if we actually wanted to do some measurements to show kind of what we measured here, to show distortion, okay, we could take a ruler and we could measure across this hippo. Okay, so the original hippo, if you see that, looks like it's about 26 millimeters across. So the width here of this one, let me just change colors here. Okay, is 26 millimeters for that width. And we could look at this second hippo and we see it's about the same, right? So that width is 26 millimeters. And I'm just measuring from here to here, right? And now if I look at this one, okay, at its widest part, it looks like that one's about 13 millimeters across. So we can see that A didn't get changed horizontally, but B did. And then we could do the same thing and we could look at this vertical measurement. And so if we look vertically, so if I go from the feet to the top of the ear there, okay, so if I measure this way, that one looks like it's about 34 millimeters up. Okay, and then if we move over to the next one, okay, from foot to top of the ear, looks like it's what, about 17 here. Okay, and then if we look over at this one, okay, we see again about 17. Okay, so let me just get that written on here when I get this out of here. But 17 millimeters top to bottom, which is half of 34, right? So when we're looking at this, the scale that took us from the original to B, they cut it in half, right? They divided the horizontal by 2 and they divided the vertical by 2. Where when we go to A, the only thing they divided by 2 was the horizontal. Okay, the vertical got left the same. So that's why it looks smushed, because it was only pushed down. It wasn't pushed down and in. So just the vertical was changed, not the horizontal. So when we're talking about scale drawings, okay, so here's just a vocabulary review. So scale drawings are just drawings in which all lengths in the drawing correspond to lengths in the object at the same scale. So in this last one, that was the dividing by 2. So everything needed to be divided by 2, not just the height, but the height and the width need to be divided by 2. And a scale tells you how the lengths correspond. Okay, so for instance, 1 inch in the scale model equals 2 feet in real life. And you can think of a bunch of different types of scale drawings, right, that you see in life. So maps, right? We have to do scale drawings for maps. You can't draw real life size maps, right? That wouldn't work. You'd be like in the real world, right? On the actual street, it'd be the same size. You see this in biology a lot when we're looking at cells. We can't see cells with our eyes. So we have to draw scale models of cells to make them larger so that we can look at them, but that they stay in proportion with what it actually looks like in the micro size that it is. Okay, you have scale models of houses, of buildings, of action figures, all sorts of things that are scale models that you could do a drawing of as well. All right, then you can put this scale factor on your reference chart. So the scale factor is going to be really, really important. And the scale factor is the factor, and factor means multiply. Okay, so a factor is something that multiplies. The scale factor is the factor by which every length in the original is multiplied when you make a scale copy. Okay, so we have this original figure, which you know I like to call the OG. So we're going to have the original figure, and when we figure out the new figure length, when we figure out the new figure length, we're going to multiply the original by that scale factor. Okay, so whatever that number is, and then that's going to equal our new length. Okay, so if we take the original length, okay, whatever it is, okay, so in this case, the original is this radius of 1, and then we're going to multiply that by the scale factor. Okay, that will give us our new length. So 1 times 1/2 gives us 1/2. Okay, and then if we did it backwards, like we could do it the other way. So if the 0.5 had been our original, if we took the 0.5, the scale factor to get back to this one would be times 2. They're reciprocals of each other, so they would flip. Okay, then let's actually look at what a dilation is. So a dilation is a motion, okay, not a rigid motion because it's going to change the size. So when we stretch something, we call that a dilation. So a dilation stretches or compresses, okay, so it can make it bigger or smaller, a figure relative to a center point. So there's always a point that it's getting closer to or further away from, and that's the center point. Okay, so it's getting closer to this point or it's getting further away. And then we use the scale factor to do that. So on this diagram here, okay, O is our center point. P is the point that we're dilating. Okay, and let me just get maybe a big segment here to like stretch this and kind of show you. All right, so, ooh, that's way too big. All right, let's try again. I don't know if it'll show up here. Okay, it's not going to show up when I'm doing it, but we would be taking this point P and we would be multiplying this original distance. Okay, so we'd figure out how big this original distance is from O to P, measure it with a ruler, okay, or if you're given just measurements on a diagram, you can use that. And then we would multiply by the scale factor, and that would pull it out to another point. Okay, or if the scale factor is less than 1, then it's going to get closer. Okay, but it's just going to move this along this line. Okay, so it's going to move it along this line that connects the center to the original. So notice that there's this line. We'll multiply by the scale factor. So down here, the scale factor is less than 1. And if it goes past here, okay, then the scale factor is greater than 1. So that'll become important to remember also. All right, so in this next activity, okay, you're going to construct 2 different dilations. You're going to need a ruler so that you can measure, and then I'll talk about it when you get finished with it. So remember that a dilation has a center of dilation and it has a scale factor, right? So we've got this center of dilation, and then we're going to have this scale factor that takes point P along that ray that connects the center to the original. So when we're doing this, okay, and I'll walk you through how you get started on number 1. So you want to find the center of dilation, okay? So the center here is C, okay? So this is the point that isn't going to move. H is going to move, okay, relative to C. So we want to connect, so take your ruler and lay it on this segment here, okay, and just extend that line. So I'm going to get a different color here and make that smaller. Okay, but lay your ruler and just extend this line. Okay, so just draw a line out because H is going to move along that extension of the center to the original. And so now you need to take your ruler and you need to measure how far it is from C to H. Okay, so measure how far it is from C to H. And don't worry about this 40, okay? So yours might be 40, it might not be because they didn't really take that into account when they made the segment in the book or on your paper. So if you need to change that, change it, okay? So mine is 43, 44, okay? So I'm going to change this to 44. So if yours is different, change this, okay? So mine is actually 44. Okay, so when I measured this, now I want to use this scale factor, right? So I take this original distance, which is 44, and then I multiply it by the scale factor, okay? And in this case, the scale factor is 3. Okay, so I'll take 44 times 3, and then after you do that, that's going to be your new measurement. Okay, so 44 times 3 gives us, let me get a different color here, gives us 132 millimeters. Okay, so every 1 centimeter, you'll see my centimeters are marked at 10, is 10. So this is really 13.2 centimeters or 132 millimeters. So I'm going to extend my ruler here. But so 10, 20, 30, 40, 50, 60, 70, 80, 90, you can see that up to 132. So here's where the new point will be. Okay, way out here at 132. So there's where H prime will be. So the original was 44. We multiplied by 3, and then we measured from C out to that point. So your center point is always going to be your 0, right? So that's always going to be the 0 on your ruler. Okay, so then this second one, okay, so measure again, it's probably the same as that top one was, okay, so I'm going to change mine to 44, and again, make sure you measure yours, make sure yours is the same as mine, or if it's different, you're going to need to use different numbers. Okay, so then this measures 44. Now, notice that the center changed places here, right? So now the center is over here. Okay, so make sure that you flip your ruler around, okay, so that's where your 0 goes. And then you'll measure to K. And you can extend that line, right? So you can extend the line so that you're measuring on that. Whoops. So lay your ruler down and just extend this out so that we know where K would go. Except in this case, K is less than 1. So K is 3/4. So we're actually going to get smaller this time. Anytime the scale factor is less than 1, your number is going to get smaller. Okay, so we're going to take the original, okay, times the scale factor. So I'm going to take 44 and I'm going to multiply it by 3/4. So in your calculator, you can type in parentheses 3 divided by 4. That's how you would type in 3/4. You can also type in 3 divided by 4 before you get started and know that that's equal to the decimal of 0.75. So you could also do 44 times 0.75. And so when you do that, you will get 33 for your new length, okay? So my new length, 44 times 3/4, is 33 millimeters. Okay, so remember your ruler, the 0 needs to be on your center. You need to go connect it to your original. Okay, so make sure your ruler is laying on the center in the original, and then measure to the new length at 33 or whatever yours is. And then there is my new point. Okay, so do we see how K prime got closer to the center here? Okay, so this distance is closer versus this distance was further away because the scale factor was greater than 1 in the first one and less than 1 in the second one. Okay, so this is the idea of how you're going to dilate. Okay, so you're going to want to make sure that you understand that. Okay, because in the next activity, you're going to need to do it. So let me get rid of this and let's write down. Okay, so remember, you're going to measure the original. Okay, so measure, and you're going to measure center, which is going to be at 0 on your ruler. Okay, to the original point. Then you're going to multiply that by the scale factor. Okay, then you're going to measure again from center at 0, right, to the new length that you found. Okay, and then plot your point. Okay, and you can label that with a prime, right? So measure, make sure your center is always the 0. Okay, make sure your center is always the 0. And then measure to your original, multiply by the scale factor, which will give you your new length. Okay, and then measure from the center out that new length and plot your point. Okay, so now you need to try this on this snowman. We're going to dilate this snowman, okay? And the snowman has a scale factor of 1/2, and you see all sorts of points, okay? So the center point here is P. So this is where the 0 on your ruler needs to be the entire time, okay? And I would use the centimeters, okay? So I would use centimeters. So let me flip this around. So let's measure to D together. Okay, so lay your ruler down, and I think this is the same on your sheet. I think ours is the same. If it's not, you'll have to do different measurements. Okay, but so my distance, and I'm going to write this down. Okay, so my distance from P to point D is 12 centimeters, right? Because 120 millimeters. So I'll just say 12 centimeters. So now I need to multiply that by the scale factor, okay? And the scale factor is 1/2, which is a decimal of 0.5, okay? So type in 12 times 0.5 in your calculator, or know that half of 12 is 6, okay? So then our new length, so P to D prime, right? So P stays in place, D prime is our new point. This length is going to be 6 centimeters. So I'll measure along this same line, make sure your ruler is touching P and D, and then you're going to go to 6 centimeters and put a point. Okay, so there's where P prime is. So you measured from P to D, you multiplied by the scale factor of 0.5 to get the new length of 6, and then you plotted that point. Now let's measure out to point C. Okay, so let's do point C together. Okay, so keep 0 on P. Your ruler should go out and touch C. Okay, so I'm going to write this down. So P to C is 11.1234. So 11.4 is my distance to C. So now you're going to multiply by the scale factor of 0.5 to figure out your new distance to C prime. So P to C prime. So type in 11.4 into your calculator and then times 0.5, and you'll get 5.7 centimeters. So make sure your ruler is still 0 on P and it goes through C, and then count to 5.1, 2, 3, 4, 5, 6, 7. Okay, so then there's where C prime is. And you're just going to do this to all of the points. Okay, so just get all of the points plotted. So you've got a bunch more to do, right? And so you've got J, you've got, whoops, I, you've got H, you've got E, F, G, A, and then B. Okay, so just try and get all of those points plotted. You don't really have to do all of them. I would say if you get maybe choose 5 points. Okay, so dilate 5 points, and then you can move on. And if you want to get the circles, the way that you get the circles, okay, would be then once you've got the center, and let me get my compass here. So once you have the center, right? So C is the center, D is a point on that circle. So then you can just grab your compass, and this is going to be a teeny tiny circle. But just get C. Oh, and I labeled this wrong. This should be D prime, not P prime. Okay, so then you can just set your compass on the center and a point on the circle, and then you'd be able to draw the circle. So there's that snowman head if you want to try that. Okay, so then when you get point A, you can get point H, and then you can connect those using the compass, because it'd be centered at A prime, and then open it out to H or E or B. Any of those points would work to get that circle. So do 5 points. So dilate any 5 points you want, okay? Or if you're quick at it, you can do all of them, and then move on. All right, so what changes size when it's dilated? Okay, so does a point change size when it dilates? So a point doesn't, okay, because a point doesn't have size. So no, the point doesn't change size. It does change place, okay? So it changes position, but it doesn't change size. What does change size, okay, is a segment, okay? So a segment changes size. Okay, it gets bigger or smaller, but still looks like a segment. So what does it look like when it's dilated? Itself, just bigger or smaller. So it still looks like a segment, just bigger or smaller. So points don't change size. Segments will still look like segments. They'll just be bigger or smaller. And then you can write dilation on your reference chart. Big deal here, right, is to make sure that's your center, that you know your center of dilation. Okay, and then you have a positive scale factor. Okay, so we have this scale factor K. We'll take point A along the ray from the center to that point. Okay, so it's gonna, you'll see this straight line connected here. Okay, so A is gonna move along that ray. So it's gonna move out or in along this straight line that connects the center to the original. Okay. And then here's a sentence frame that you can use when you're talking about dilations. So we dilate what object using what as the center and what scale factor. Okay, so we're going to dilate triangle ABC using P as the center by a scale factor of whatever it is. Okay, in this case, it didn't give us one, but K. And then another thing that I would make sure that you have written down somewhere is that your original length times your scale factor, okay, equals your new length. Okay, so the new equals the OG times the scale factor. That will keep coming back over and over and over. So you want to make sure that you have a handle on that. Okay, so hopefully now you know how to dilate a given figure, given a scale factor and the center. And then you can work on the lesson 1 practice problems to check your understanding. There is a video. I do have a video for that if you would like to check it out. It's Unit 3, Lesson 1 practice problems for geometry. You can also work on this cool down to try to match these scale factors to these pictures. Make sure that you notice the originals don't have primes, right? So here's your original F to G. So look for that in each drawing. And then it's labeled, so you can always do the original times the scale factor to see what it is. Also, you can think about the fact that if it's getting bigger, then the scale factor is greater than 1. Okay, so this number right here is 1.5. This is bigger than 1. 2 is bigger than 1. 2 divided by 3 is 0.6 repeating. Okay, and 1/2 is 0.5. So go ahead and you can either multiply the originals times that to match the numbers. You can also kind of look at bigger or smaller to help you out there.